and welcome back to this advanced workshop on Power Pivot. Today we're going to upgrade our knowledge of pivot tables to its final form. What we're going to be looking at as a result is what Power Pivot is and how to activate its add-in, the role of a primary key and why it is necessary to set up a relationship in a data model, how to bring data into Power Pivot by importing from a separate source, as well as adding existing tables from within our own workbooks. Now, once the data is in our model, we will need to link it so we can draw accurate conclusions. I will show you how to use the diagram view to easily set up those relationships with a very user-friendly click and drag user interface. We will also look at DAX calculations, measures, and more. This is all new to you. Worry not, it will make a lot more sense once we get hands-on with the example. So let's get started. What is Power Pivot? Well, Power Pivot is an Excel add-in that allows you to perform powerful data analyses by creating data models and building relationships between the sources making up those models. As I have alluded to, with Power Pivot, you can use multiple tables as data sources for a pivot table, which is what we will be exploring today. Now here I have two separate Excel files, which I'm going to be using for this example: student data and tuition data. I will open student data first so we can investigate. Now, if you have never used Power Pivot in the past, to activate it, type Power Pivot in the search at the top of your Excel title bar. Power Pivot, and there we can see go to the Power Pivot window. Click on that. You will be prompted to enable the plugin, so click Enable. And now you should see both the ribbon item, also the manager may have opened for you automatically. We can close out of this for now. Again, you should see this Power Pivot ribbon item on the far right. Now, before we dive into the example, there's a very important concept we must establish: primary key. A primary key is a unique identifier for each row in a table that can be related to other tables within our data model. Having a primary key means that when we query for a specific item, we will always get the correct result. Think of document IDs in iManage, for example. When you run a document search on a document ID, you will always find that document in question without fail. So, a unique ID would always be the best way to approach creating relationships between tables with related data. However, there are some workarounds. If a unique ID is not present, you can combine multiple columns to create something akin to a primary key. For example, you could concatenate a name column with another column containing more granular data with the goal of creating a completely unique sequence. The column with the concatenated data will now be used to test against as the key. A constructed key made to act as a primary key is known as a composite primary key. A foreign key, on the other hand, represents a column in a table to which you are creating a relationship. Now, because we are testing against this table, its values can contain duplicates or be null. This might all seem very confusing at this time, but I just wanted to kind of plant the seed in the back of your minds, and we will explore how these keys actually function when we connect and create the relationships in our model. So let's put this theory into practice and see how we can use these keys to establish relationships. Now, the first thing I want to do is to examine my data. As you can see, we have a few tables with a variety of student information. We have their grades, we have their student details, we have the various classes that they may have participated in, and of course, the various semesters where those students may have participated. Now, under our student details, you may have noticed that we have a student ID column, which you would be correct in identifying as the primary key. Again, each student number is unique to a single student, which makes it the perfect primary key. Our first step is to take these tables and create our data model. So for the time being, let's close this document, but keep Excel open. I want to explore the second document, which is that tuition cost worksheet. So opening our tuition cost worksheet, we can see that we also have a student ID column. Fantastic. Now I want to merge all of this data together. How do we do it? Well, there are a few different ways that we can import data. Let's start by examining the core Power Pivot interface by clicking on the Manage button. Again, on the Power Pivot ribbon, it's going to be the first button on the top left. If we examine the Get External Data document group under the Home tab, you will see that we can grab data from databases, for example. We can search for data services, and we also have from other sources. The list is pretty complete, but we are mostly going to stick to Excel today. So if we scroll to the very bottom of this list, we're going to find Excel files. Select that, click Next. Here we get to determine which Excel file we want to bring in, and conveniently, we can click on the Browse and select our student data. So here I am in my local folder where I have saved both of my Excel documents. I'm going to choose student data. I'm going to press OK. Perfect. Now we have a couple other options for testing the data as well as advanced settings, but for the purposes of this introduction, we can just click on Next. I know that our 4 tables do in fact have column headers since we just inspected the data, so I will make sure to click the Use First Row as column headers and then again hit Next. Now we can see that we have successfully found all of our tables. If you want to double check how your data will be imported, you can click on any of the tables and select Preview and Filter in the bottom right. Again, you can expand this window. You can expand the columns, make sure everything is exactly as you expect. I'm going to click Cancel. I will inspect the next one as well. It is a best practice to make sure you're taking a look at your data to ensure that it is clean. You have all your headings. Everything is as expected. Now, in this case, I know that all of my tables are clean. I know as a result, they will execute as intended. So all I'm going to do is I'm going to click on the box to the left of source data to select all of those tables. And I'm simply going to click the Finish button. The more data you have, the longer this can take to load, but generally speaking, as you just saw, it is relatively quick. Now, everything got the green check mark. Fantastic. We know they have been imported successfully, so we can click on Close. Now we can see all 4 of our tables as identified by the tabs with their names at the bottom of our data model. Great. But what happens if you already have tables in your working document? How do you import them into your model? Well, let's not forget about our tuition table. And if that is the case, it is even easier of a process. We can close out of our pivot table environment, and to bring in our tuition table, all we need to do is to click within any cell in this table and then click the Add to Data Model button on the Power Pivot ribbon. There we have it. Our tuition table has been included, and it is now time to set up the relationships. The method I would like to share with you today is using the diagram view as it is available in our View document group. Once we click on it, we will be presented with a visual representation of all of our tables. You can move these around, you can resize them if they have additional columns that you cannot see. And once you're happy with organizing them in a position that makes sense, we are ready to set up the relationships. Now, the way to do this is to click and drag our primary key into the tile that has our foreign key. As an example, my student details block contains a student ID field. I can click into that field and drag it into the student ID field in the grades block. This creates our first relationship as outlined by the line linking both of our blocks or tables. Similarly, my grades table has a class ID field. Like before, I can drag the class ID field from the grades table to the matching class ID field in our classes table. To finish setting up our relationship, we can drag the semester field from the grades table to the semester ID in our semesters table. This is another reason to double check your data first every time. Even though the semester column in our grades table is not labeled as being the ID, we know that it is because we inspected our tables earlier. Finally, we can drag our student ID from the tuition table and match it with the student ID in our student details. Perfect. Now you might ask, does it matter which table I drag from and to first? The answer is no, it does not matter as long as they share a key. Now that we have established our relationships, which are visually represented by the connecting lines, how do we interact with same? If we right-click on any of the lines, we will be presented with a few options. We can temporarily mark a relationship as inactive if we didn't want to reference that data in our model. We can view the primary key link by clicking the Edit Relationship button. And of course, deleting a relationship can also come in handy when it proves to no longer be relevant or when it was accidentally linked to the wrong key. However, the Edit Relationship button is equally useful for that purpose because it lets you double check to make sure you are connecting the correct column. And if not, you can adjust the columns from the drop-downs for each of the tables. So in this case, we are targeting the grades table, we have the semesters table, and the two columns that are being highlighted, semester and semester ID, again, another visual representation, letting us know that we did in fact connect the correct columns. So you can choose the table from the above dropdown, and then you can click on the column you like to link. Okay, let me cancel out of here. And you may have probably also noticed there is a 1 and an asterisk at either end of the lines. The 1 represents the side where each row is unique. In other words, where only one instance of the primary key side of the relationship is found. The star represents the many sides of the relationship. This indicates that for every value in a column, there can be multiple rows in that table. For example, we have a student ID as our primary key. Only one student can be assigned any given ID. However, the star can represent a table where the student appears multiple times as part of many courses or many semesters being participated in by said student. Again, as a quick review, this is what we call a foreign key. One of the main advantages of using a data model such as this is that you can perform additional calculations on your data without having to adjust the original source material. What does that mean? Well, you can add columns directly in the model without having to go back to the tables and running the calculations there. Not only that, but because we have already generated our relationships, you can do this across all your data sources. Data Analysis Expression, or DAX for short, is the language used to run these calculations. This sounds complicated, and that's because it is. I'm kidding. Like with everything, the more your skill grows, the more complexities you will discover. DAX does operate very similarly to how regular formulas are structured in Excel. One of the core differences between the two, however, is where Excel formulas target a cell or a range of cells, DAX formulas are all about context within a data model, and as a result, will generally operate on tables or entire columns within said model. Let's swap back to Data View. As an example, let's say I want to run a quick check and make sure all the students were charged the same amount per course. I can simply double click into the column header, add column, and I'll name it price per course and press enter. This will activate our new column, and in the first cell, I can begin typing my formula. Because we can reference any column across our complete data set, we must specify which table we are drawing information from. Tuition is our table name, so we will choose tuition. Now, as you can see, it will autofill just like with regular formulas, but in this case, we are presented with tuition, and the contents in brackets represents the column within the said table. In this case, I'm going to choose tuition per course. And what I'm going to do is divide this by tuition and enrolled courses. When I press enter, this will autofill our data across the entire table, the entire range. We can now rest assured that every student is in fact being charged exactly $1,750 per course. You can also create a measure. A measure is a dynamic calculation that is updated based on data that it references, and it carries forward into a pivot table and or a corresponding pivot chart. Again, because we are performing our calculations on the data model, we benefit from the automation of having our calculations updated in real time across our applications. Here is an example of a basic measure. Let's assume that I want to know the average cost per student per course. In the cells below the line, and it doesn't matter which one of these you pick, as you can see, I'm clicking across the entire range, we can start typing equals and average. Again, it's going to autofill like much the same way as you've seen with regular formulas in Excel. While at the same time, again, just like with a regular Excel formula, below the syntax outlining what you need to enter to make this formula function. In this case, it's asking us for a column name, and that is where we're going to enter tuition and tuition per course. I'm going to double click that. We have to wrap our parentheses, or close our parentheses rather, to finalize the expression, and we can press enter. We can click between the cells and create a little bit more real estate just so we can see what is happening there. And by default, we can see that this measure is called measure 1. If we're not happy with that, we can click into the formula bar at the top and rename it to whatever we like. In this case, I'm going to change the name to average cost per student. Again, press enter to accept your changes. Now the formatting is a little off, and fortunately this carries over from traditional Excel as well, wherein we can right-click, select Format. We can choose this as a number or a currency, change our decimal places to whatever we like, and press OK. There we have our final form. We can run measures and we can add additional columns with calculations. Why does this matter? Let's create our pivot table and we can see why. Now we can do this directly from the pivot table button above on our ribbon. However, I want to show you a different way as we can do it directly from Excel. So again, I'm going to close out of this environment. And now that we're back in Excel, I can click on my Insert tab. There is our pivot table dropdown. So when I click on that, we're not creating a pivot table from a table range or an external data source, but we are going to be creating this from the data model that we just set up. So I'm going to select that. I'm going to put it into a new worksheet, and I'm going to press OK. So what are we seeing here compared to the regular pivot tables we created in the intermediate workshop? Well, if we investigate our pivot table panel on the right, we can see all 5 of our tables are available as data sources. So if I expand the tuition dropdown, for example, We now also have access to that measure that we created. There's that average cost right there. We can see that because it has the FX tag in front of it. We can also see the tuition per course column, which we also created ourselves. And of course, if we expand to student details, we can see all of the columns as they existed in all of the tables, which we loaded into this data model. Now I can go ahead and create my pivot table the way I would normally. So if I wanted to be able to filter by student ID and see how well the students did in classes across the various semesters, I would put my student ID from the student details as my filter. There we go. From the class tab, I can then choose the class name, and I can drop that one into my rows. From the semester table, I can choose semesters and drop that into my column. And finally, of course, the data that we are interested in, the value that we are interested in is going to be the grades. We can put that into our value column. Perfect. Now, as we can see from our grand total column and our total columns in general, we are doing a sum of all the grades. That is not what we want. And as we learned in the intermediate workshop, we can click on the drop down of our sum of grades value. We can select value field settings. Let's change that to average. And we want to make sure that we go to our number format, choose number, and we don't want any decimal places. We'll just leave it at 0, press OK again. Now, before we move on from measures, I do want to talk about them just a little bit more. Just like with the formulas tab in Excel, where we have the ability to insert a function as we explored in the intermediate workshop, with Power Pivot, if we go back into our Manage Environment and we click on the Design tab in the top left, we have our Insert Function button here as well. So this will serve as a catalog of all of the DAX calculations that you could potentially use, and it will give you access to scroll through them. You can click on the various categories and see what each one is going to be able to provide for you. Now, arguably, the most powerful DAX function in Power Pivot is called Calculate. This function is like a Swiss Army knife of data modeling because it lets you modify the context in which a calculation is performed. In a way, you can think of it as a pivot table referencing a pivot table. So pivot table inception of sorts, I suppose. Now, Calculate does supersede all other filters and will continuously display the data you are referencing. So it is an incredibly powerful tool in drawing inferences from your data set at large. The syntax will make this very apparent, and this is what we're going to look at now. So the calculate syntax is simply calculate expression. That's where we enter our logic and or our calculation. And then we have filter 1, filter 2, so on and so forth. So if the expression is your typical base measure like sum or average or any other calculation you might want to run, then the filters are where the magic happens. They allow you to reshape the context. Now, if we look at our data here, and if I go into our column label dropdown, we can see that we have a little bit of an outlier. That is, we only have one entry from 2014, the fall 2014 session. Well, let's use DAX Calculate to create a filter so we can compare the grades from the fall of 2014 and see if there's anything interesting happening in our data. Now, there are a number of different ways to add a measure. We have already explored opening the data model and then creating the measures at the bottom of our tables. We can also right-click on any of our tables in our pivot table fields. As you can see, you're able to add a measure directly through the right-click. And also, if we look on our Power Pivot ribbon, we have our measures drop down and we have the ability to add new measures, and then of course, manage them as we create them. So that is exactly what I'm going to do. I'm going to click on add a new measure. This is going to give us that visual interface so we can see exactly what is happening. And the first thing I'm going to do is I'm going to name this measure Fall 2014. Perfect. Now here is a brain teaser for you. Does it matter under which table we're going to be placing this measure? Currently, it's going under classes, but will that affect our calculation? The answer is no. In principle, because we have set up our relationships and all of our data is interconnected, it does not matter under which table we create the measure. That being said, from an organizational standpoint and just structuring your data in a very effective way, it is in your best interest to place the measures in accordance with your best workflow practices. So we're going to start with equals calculate. And again, as you type, it will autofill. You can press tab to insert the formula. And what is the expression that we are looking for? Well, let's do average grade. We're going to type in average. Again, that will autofill for us. This is the syntax. And now we can choose grade in square brackets. So to review, we're choosing the grade column from the grade table. I can double click on that. Perfect. So now we're going to close our parentheses and we're going to press comma to move on to our very first filter. And here is again where the magic happens. This is where we get to specify that the only data that we want to see is from that fall semester of 2014. And if that is the case, then what is our filter going to look like? Well, I'm going to choose semester. I want semester and semester name. And then I can type in equals. And as we learned in the intermediate workshop, when we want Excel to consider our text as just text, we're going to enter quotes and type in the name, which is fall 2014. And then we can close our expression with that closing parentheses. We can check the formula with the check formula button to ensure there are no errors. So no errors in formula found. And I can press the OK button. Now, as previously mentioned, filters through Calculate will supersede those created by the pivot table. In practical terms, this means that regardless of how I modify the existing filters, those dictated by the formula will stay the same. So what does that mean? Well, I can go into my column labels here for the semesters and I can turn everything off. And let's say I just want to compare the winter semesters from 2015 to 2018 to that fall 2014 session. So there we have it. The fall 2014 does not move from our data set. It supersedes what we're doing with the filters of the general pivot table. And on that note, we should also fix our averages for fall 2014. Again, on the dropdown, we're going to change the value field settings. We're going to go to number, and just change it to 0 decimal places. Press OK again. So where do we find this measure? Well, as you've probably already guessed, if we expand our dropdown, there is our FX fall 2014. And of course, if we go into our measure dropdown and click on manage measures, we're going to be able to see the measure there as well. And we can click edit, go back into the user interface and make any changes that we require. Now, another thing that we can do is to create a KPI or key performance indicator. This is a useful tool for the purpose of visualizing our metrics and making our fall 2014 grades pop on screen a little bit more. To create a KPI, we need a measure first. Now, we already have the measure in question. We've just created our fall 2014. So what we can do now is go to our KPI dropdown and choose New KPI. Now, at the very top, it's going to show us the two measures that we have available to us, and I will choose fall 2014. As you can imagine, I will use absolute values, and again, you can choose the icons, you can choose the thresholds. This is very similar to the data bars that we explored in the intermediate section. I'm just going to leave everything as default and press OK. Now, immediately they will not appear on screen because we have to refresh our data really quickly here. So under classes, you'll see that traffic light icon for fall 2014. If we expand that menu and we unclick FX status and we then go back in there and recheck that, now you're going to have the icons with their respective values immediately beside. So this will give us, again, a visual representation, and we can have a general idea of how fall 2014 stacked up against the winter semesters, and then, of course, the average overall of the grade. Now, of course, these are part of our pivot table, so we can always come in here. We can turn off all of these various values. There we go. And we can restore our data to whatever we like. Just as a reminder, if you don't want to use the drop-downs, you can always insert slicers, as we learned in the intermediate workshop. That will make it a little bit easier to navigate and choose not only the data that you're interested in, but depending on which slicers you're inserting, you can get feedback about which data is relevant to each slicer. Thank you very much for participating in this advanced workshop. There will be more to come, but if you'd like to have an advanced topic covered, please let me know. Again, thank you for your time, and we'll see you in the next one.